As tensions mounted in the Persian Gulf, Space Systems Division, SSD, accelerated its efforts to provide extra support for Operation Desert Shield and then Desert Storm, while continuing its research and development activities. The newest Defense Meteorological Satellite Program, DMSP spacecraft to be launched, was placed in position on orbit to support our Middle East operations. And as requested by Air Weather Service, a high gear project was established to provide our Persian Gulf forces with the Rapid Deployment Imaging Terminal, RDIT, a lightweight, highly mobile DMSP terminal. RDIT weighs less than 2,000 pounds, compared with the 26,000-pound Mark IV tactical weather terminal, and has basically the same capability. As the report period closed, 2 alternative RDIT systems were being evaluated. Specifically to support Operation Desert Storm, Air Force Global Weather Central installed and is now using operationally a new multi-channel cloud analysis technique. SSD provided technological support and facilitated implementation of this superior method for analyzing weather data. This analysis is particularly useful for aiding sorties by detecting low-lying clouds and fog at night. The latest Navstar Global Positioning System, GPS satellites to be placed on orbit, were positioned to provide maximum accuracies over the Persian Gulf area. 24 hours a day for 2D coverage and 20 to 22 hours a day for 3D coverage. The area shaded with lines indicates degraded 3D coverage. The moving symbol is a GPS satellite. In building the Navstar GPS constellation, we are aiming for a total of 24 Block 2 satellites, 21 plus 3 operational spares on orbit, 4 in each of 6 planes around the Earth. We now have 10 Block 2 satellites on orbit and 6 older Block 1s, which are exceeding their design life. The first of the Navstar GPS Block 2A satellites, which have improvements that increase spacecraft weight by about 200 pounds, was launched during the report period. The launch vehicle for this flight was the first of the new model Delta II, which has improved solid rocket boosters and a modified main engine to support the new spacecraft configuration. Because not all U.S. and Allied aircraft operating in the Middle East are equipped with Navstar GPS equipment, SSD invented, managed, and delivered an innovative, low-cost, rapid response system that provides precise fixed points for navigation in open terrain. GPS equipment is used to position easy-to-identify radar reflectors, which are then available to update inertial navigation instruments on board aircraft. As of the end of January 1991, more than 4,000 Navstar GPS receivers are in use for operational missions. That figure includes approximately 2,700 of these small, lightweight, handheld GPS receivers, shown here during field exercises. These units were rushed to the Middle East in addition to a complement of rugged military receivers so that more of our Persian Gulf forces could benefit from GPS accuracy. Our Defense Satellite Communication System, DISCUS spacecraft, handled up to 80% of all communications in and out of Operation Desert Storm. DISCUS 3 spacecraft are being modified for launch on Atlas II boosters. The new satellite propulsion system required for use with this booster, shown here in a test firing, and the Atlas II launch vehicle itself have been designed, developed, and produced in parallel on an accelerated schedule to meet a projected launch in the spring of 1991. During the report period, we successfully accomplished mechanical and electrical integration of the entire Milstar communications satellite and began the final series of tests that will lead to satellite delivery in 1992. And we continued ongoing testing with an extremely high-frequency package mounted on 2 Fleet Satellite Communication System, FleetSatCom spacecraft, to validate the portion of the Milstar payload that links the satellite to user terminals on land on sea, and in the air. Launch recovery resulting from the Challenger tragedy and the back-to-back failure of two Titan boosters is well underway. Through the end of January 1991, SSD has achieved a string of 49 successful flights in which we have had responsibility for the booster, upper stage, or spacecraft. On October 1st, 1990, SSD transferred responsibility for space launch operations at the Eastern Space and Missile Center and the Western Space and Missile Center to Air Force Space Command. Under combined test forces, SSD retains responsibility for Titan IV, Titan II, and Atlas II launches until the operational capability for each has been demonstrated. To meet growing needs for satellite command and control, we are completing the development of the Consolidated Space Operations Center, CSOC. Many elements of this modern command and control center are already operational. On January 10, 1991, in a ceremony at Falcon Air Force Base, our CSOC program office successfully turned over the Weather Support Unit, the first of 4 key systems to be transferred to Air Force Space Command. We are also transferring on-orbit control of operational satellites to Air Force Space Command at CSOC after turnover criteria have been met. To date, this has been accomplished for GPS, DMSP, FleetSatcom, and NATO 3 spacecraft. And we expect to transfer on-orbit control for DISCUS and the Defense Support Program, DSP, in the near future. Air Force Space Command presently uses CSOC to control 2/3 of operational satellite missions. We are automating the Air Force Satellite Control Network's remote tracking stations. This program adds needed satellite communications capacity and reduces the number of technicians required to operate each antenna system from 9 to 2 for each shift of around-the-clock operation. We started with 12 antenna systems at 7 stations. When the automated remote tracking station program is completed, we will have 16 antenna systems at 9 stations. The Saipan radar program was turned over to Air Force Space Command, and the command began operational use of the system. This completed 9 years of work to fill a critical gap in tracking Soviet and Chinese space launches. At the end of 1990, the new Phillips Laboratory was formed to consolidate the Space Technology Center and its astronautics, geophysics, and weapons laboratories.
From these 3 separate laboratories and the other management realignments, we are creating a new lab structure which integrates the many space and missile technologies and gives us what we call a critical mass to realize a research center that will truly become world-class in nature.
The new Super Laboratory will continue as an integral part of SSD. The Air Force is studying the gradual migration of portions of the geographically separated laboratories to the headquarters at Kirtland Air Force Base, New Mexico. The Combined Release and Radiation Effects Satellite, CRESS, was placed on orbit in a joint DoD-NASA effort to better define the near-Earth environment, including radiation belts in the ionosphere, and its effects on the sensitive microelectronic components of space systems. DoD's portion of the program was managed by our Space Test and Transportation Program Office, and 18 of the CRESS experiments were sponsored by the Geophysics Directorate of our Phillips Laboratory. Preliminary data from this experiment is validating and improving our understanding of the space environment. This new knowledge will have a significant impact on satellite design. The Propulsion Directorate of our Phillips Laboratory successfully flew the first in a new generation of prototype kinetic kill vehicles, applicable to Brilliant Pebbles space-based interceptors, one of the programs we manage for DoD's Strategic Defense Initiative Organization, SDIO. The new vehicle weighed less than 40 pounds, compared with the 220-pound functionally equivalent prototype which was flown in 1989. The SDI program had been focused on deterring massive Soviet attacks on the United States. In his State of the Union address, President Bush announced a change.
Looking forward, I have directed that the SDI program be refocused on providing protection from limited ballistic missile strikes, whatever their source. Let us pursue an SDI program that can deal with any future threat to the United States, to our forces overseas, and to our friends and allies.
Brilliant Eyes is now being redesigned to meet this new requirement and also to support theater missile defense. We began the proof of principle phase for Brilliant Eyes, during which we will investigate key mission performance approaches and demonstrate the function of key hardware subsystems. We are continuing in the demonstration validation phase for the Advanced Warning System, formerly known as the Boost Surveillance and Tracking System. Program responsibility and funding have been transferred from SDIO to the Air Force. The Wide Area Surveillance Program was reviewed by the Defense Acquisition Board, which approved an extended concept exploration phase and targeted a demonstration validation phase to begin in 1994. This effort could lead to development of a constellation of 6 spacecraft and 3 relay packages, which would provide detection and tracking of enemy forces anywhere, anytime, in any weather. As the report period closed, the men and women of Space Systems Division continued their commitment to support whatever additional actions would be required in the Middle East or anywhere in the world with superior space systems. DMSP, Discus, FleetSatCom, and Navstar GPS.